Here is an explanation for the answer to final exam question number 92 in Electronics Demystified second edition. If you have the printed book, you'll find this question at the top of page 438. We're asked to fill in the blank in a sentence to make it true. Radio waves travel approximately blank as fast along a typical antenna element as they do through a vacuum. In other words, how fast do radio waves travel along an antenna element like either one of these, the half-wave dipole or the ZEP? Just as examples, wire antennas these usually are at shortwave radio wavelengths. How fast do the radio waves travel along these elements as compared to their speed in free space? Well, you may remember that the speed of light in free space is approximately 300,000 kilometers per second. But along a wire like this, the speed is only about 90 to 95% of that value. Let's assume for a moment that it's 95%. Then 300,000 times 0.95 is about 285,000 kilometers per second along a wire element like this, as opposed to the free space velocity or speed. Well, if you have a half-wave antenna like an open dipole or a Zeppelin antenna, you can calculate what its length should be in feet or meters using certain formulas. And right here I have written the formula down for calculating the length for a half-wave length antenna like a ZEP or a dipole in feet, given the frequency f in megahertz. So, for example, if we have an antenna at, let's just say, 7.1 megahertz, then the length in feet is going to be 65.77. That's roughly 65 3/4 feet, just a little less than 66 feet. Well, when you actually build an antenna, a wire antenna for 7.1 megahertz, and decide to string it up, say, between two trees in your yard to operate on the 40-meter ham radio band, just an example, 40 meters being the 7 megahertz, 7 to 7.3 megahertz in the United States ham radio band. If you decide to do that, you're going to have to trim the antenna. You're going to have to trim it and experiment. You might want to start out with, say, 68, 69 feet and trim it back bit by bit until you get a resonant condition. You can determine that using a standing wave ratio meter. Once you find that resonant frequency by trial and error, then you know you've got the proper design of an antenna. But in this particular question, the answer is E. About 90 to 95% as fast along a typical antenna element as the radio waves travel through a vacuum or free space.